Hi everybody, this is Mark Schuyler. I want you to take a look at the two lines that I have here on our screen. Y equals 4x plus 2 and y equals 2x plus 4. And I have a question for you. The million-dollar question is, do these two lines intersect? Well, what are the only kinds of lines that do not intersect? Think about that. That might help. Of course, parallel lines. We know that lines that are parallel to each other, that's the symbol for parallel in math, they have the same slope. They'll never intersect. They're like train tracks running parallel forever. Well, do we have the same slope? We have a 4 over 1 and we have a 2 over 1. No, we do not have the same slope. So these lines will intersect somewhere. It may not be anywhere near the origin. For all we know, they'll intersect 1,000 miles away in quadrant 3. But they will intersect eventually. So that's a quick way of answering the million-dollar question. Different slopes, they will intersect. Same slopes, they're parallel and they won't. But the SAT goes a little further than that. They're also going to ask you the exact XY coordinate where these will intersect. And you need to be able to come up with that. So take a second and think about what you would do to get the exact coordinate point where they intersect. And if you're drawing a blank, one thing to think about, it's kind of a big hint. Let me change colors here. Use bright red. Isn't it true that y equals y? Yeah, I mean, that's a true statement if there ever is one. Y equals y. Well, that means their equations are equal to each other. So we should take a minute right now and set the equations equal to each other. Did you notice how these equations are making heavy use of the integers 2 and 4? That's not a coincidence. The SAT is doing that purposely. I don't know if it's a test to see if we're dyslexic or not, or if we're just going to make a silly mistake with these numbers, but they're using them in interchangeable places for the slope and for the y-intercept. All right, so we've got our equation. We follow the 3 golden rules of algebra at all times. So we have to combine like terms. I want all my x's on one side. So I'm going to subtract the 2x's. From there, they go away, but over here, I still have 2x left. I'm going to subtract 2 from this side and from that side. It goes away over here, and I'm left with positive 2 on the right side of the equal sign. So I have 2x equals 2, a single x equals 1. We're halfway there. We know the x coordinate of the point of intersection. How do we get the y coordinate? Just take the x back to either one of the equations. It won't matter which one. You could take it to that one, or you could take it over here to this one. It'll work out to the same y value. Whichever equation looks easier is my rule. So I'm going to bring it over to the first one. 4 times 1 is 4. 4 plus 2 is 6. We have the point 1, 6 is the point of intersection for those two lines. Pretty easy, right? Okay, let's look at this slide. It's a step up in difficulty from when we were trying to find the intersection of two lines. Here you can see that I am using one of the two lines from the previous slide, y equals 2x plus 4. You can see I've already drawn it in here into the Cartesian grid. What I want you to notice is the equation in red. This is not a line. I'm sure you recognize that it's a parabola, and it has a y-intercept of 1. So many of my students have a very hard time finding the intersection of a line and a parabola because there could be one intersection, there could be no points of intersection, or there could be 2 points of intersection. But you still can do this quite easily. by working with the equations. You don't actually have to work with graph paper and the XY coordinate grid system. That's nice, that's visual. I'm doing it here to just make sure that you see everything, but you should be able to just work with the two equations like we did in the last slide. What we should be seeing is that if y equals y, that means their equations are equal, even though one equation's a line and one's a parabola. So let's write them out. 2x plus 4 is equal to x squared plus 1. And we want to try to factor this. We want to get a hold of what x is. It could be 1 point, it could be 2, maybe no points. Let's check and see by moving everything over to the same side of the equal sign. That's my idea. Let's subtract 2x from this side, and that means it goes away over here. But now we have x squared minus 2x. And now we're going to have to minus 4 and minus 4 here. But 1 subtract 4 is negative 3. And all of this can now be set equal to 0 because all of it's gone from that side. Instead of writing the 0 over here, I am going to write it on the other side. Just a little bit easier. You're used to seeing it like this in school. So we want to factor this. I'm hoping it'll factor beautifully. Let's see if it does. So we need to figure out what two numbers multiply to negative 3, and yet they add to negative 2. They multiply to negative 3, add to negative 2, and I have just thought of something. It is, let's see, it would be negative 3 and a positive 1. That's right. Negative 3 times positive 1 is negative 3, but negative 3 plus 1 is negative 2. Yes. Now remember, the x values here of our points of intersection, looks like we're going to have 2 points of intersection, doesn't it? Those x values are not negative 3 and positive 1. You have to be really conscientious, really careful, and set each of these binomials equal, one at a time, to 0. And you'll discover that the x values are actually, the signs change. The x values here are 3 and negative 1. Now what I'm going to do is write that out. Let's see, how about over here? We think we're going to have 2 points. So the x value of that point, and we're going to have the x value of this point. We can go out and figure out the y values. How do we do it? Well, remember what we did in the previous slide when we just were trying to find the intersection of two lines. We figured out the x, and there was just one x to figure out. Here we have 2 of them. But you took that x and you brought it back to either one of the equations. It didn't matter which equation, whichever one was easier. That's my rule. I'm going to bring it back to the line. That would give me 2 times 3, 6 plus 4. We have a y of 10, where the x is 3, the y is 10. But if I put in the negative 1 into that same place, 2 times negative 1 is negative 2. Negative 2 plus 4 is 2. So we have the point negative 1, 2. Now, I'm going to attempt to draw in the parabola. It's an attempt because I'm not an artist, but here's our y-intercept at 1. And we know that parabolas are very symmetrical. They are going to look exactly the same on both sides. Okay, see, that's like a perfect line of symmetry on the y-axis coming down. So we see there's an intersection. Let me change colors. I'm going to go for this radioactive green. We see a point of intersection right about here and one right about there. Now, you could, if this were a graphing calculator, figure out those exact points by tracing them or looking at them, but we can just use straight algebra, right? We know the points are 3, 10, and that looks about right, doesn't it? 3 comma 10. And this point over here in quadrant 2 is about -1 comma 2. We have them exactly. We don't have to rely on being able to read the graph precisely because the algebra allowed us to set the two equations equal to each other, solve for x, then plug in for y. So there you've seen it. We have found points of intersection of a line and a line and a parabola. Once again, good luck, and may you raise your scores.